All right, very warm welcome to this session on AI and machine learning of the software engineering course. This time we are taking a deep dive into understanding how the novel engineering approach can be utilized together with agile software development process to develop a project, test a project, and then finally learn how to code, decode, and also build your own project in Python. So that's the idea today. And here are some of the slides that I'm starting with. So let's go here. First of all, this is the one. Let me take that one. So this is the topic that we are doing. My name is Mr. Rasmandari, and I teach software engineering as well. So what is AI-based evaluation tool? That is the idea that we want to track in this project. So when I have a software support or AI support to evaluate assignments and exams, that would be handy. However, like Cambridge University has been doing this in ad hoc mode. They have been using this from person doing the AI's check, and then if the AI has difficulties in understanding the responses, then it goes to a human checker, and the human checker actually finally gets to the next level of checking and fine-tuning and then publishing the result. So this can be very handy for the evaluation system, and here we're using agile methodology. I will bring this to global engineering later, but now I'm just using this brainstorm, design, development, quality assurance, and deployment cycle. Build, measure, learn, loop, going in a cyclic manner. So that is the basic philosophy behind the project. And then in machine learning, the data sets, whatever we have, we divide the data sets into 3 sets, subsets. And in the first set will be 60% data will be used for training. And then when you do this training and evaluation of the model, 10% of the data will be used for validation. And the last 30% is used for final performance test. And this is a cyclic process here before the model actually gets to the best performing model. So here in Google Collaboratory, we have a file that we can check very easily. And this one, I think this is open here. It's not yet here. I have opened it here. So this is the one that we have. All of these things are dependencies. So if you think this part, this chunk, this part that is actually the dependencies that you need. So even we have installed the transformers, the engine behind the AI. And then in this section, we need to actually read the folder here by mounting the G drive and putting the data into G drive. And here, then define the preprocesses function to preprocess the contents of the file. So we have to understand the data that we get, the files we get will have stop words, will have all different split items and contents, and we'll have to clean all of those before checking. And then now evaluate function to evaluate this code for the file. So now you have to really train the X variables, the X sets, these are features, and then your target variable. Once you have done that, then you do this complete cycle, and you read all the files from get a list of all the files in the folder that we have here. And then when you have that read, then you look through each file in the folder to read and append the scores as per the given input, given criteria, given rubrics. And then output the scores for each file into this format. That's the way that it can be done, right? So we are still working on this, right? So BERT-based on-case model is actually used in the AI model, and that will actually give more ideas into how to tokenize, how to do all the processing, and then how to do predictions and quality scores. And once we have the ranges, like less than 50 is some label, less than 60, greater than 50 is scored 0, greater than 50 is scored 20, 40, 60, 80, 90, and this kind of if and else if book can be used. Scored due to 99% based on the quality of the content, because this is determined by the rubrics given by me as a teacher. And then based on that, you come up with the whole process and then test it in the calculation mode. This error, there is an error in this system. In this system, you have to have short stack overflow to solve this problem. Because this is inbuilt for you to try and solve these kind of issues, like what is this issue? So if you click this one, it will take you to stack overflow, and then in stack overflow, you will get this kind of ideas which error it is. And then if you click that one, for example, then it gives all community resources that you have to solve this problem. Many people have tried it in the past, and then they actually guide you on solving this issue. Right? So that's kind of the editable file that will help you to actually sympathize, empathize, taste, and interview and everything. Recently, after implementing this in the class, we have, in first iteration, we tested it. And then this is my second iteration of the material. And there we had a long discussion on the review meeting. What are the challenges we are facing and how we are actually getting further into the system. And then if you really want to understand how novel engineering works in that process to understanding all of these ideas, then you have the whole resources in this link, that's your link that you can get from all of these notations. So here the idea basically is you have to frame the problem well, with understanding requirements, then conceptual planning of solutions, realizing and testing ideas. In the original video, we assumed, in the first video, we assumed that the program will read PDFs. But normally, now PDF needs to be converted into text, and the text files are actually used into the analysis. So rather than collecting PDFs, now students are actually designing requirements where the students are requested to upload their Word documents. That way, framing the problem and understanding the need is very, very important. Once you have understood that, then conceptual planning of the solutions which I have done in the diagram, like how to train, how to validate, and how to test, that was the cycle that we did in this slide. So if I recall these slides here, so if you look at this one, you have training the model, evaluating the model, and testing the model. In that process, you get to really have iterative loop that gives you a feeling of enjoyment and also a sense of achievement all the time you come up with a better solution. That way, we will be able to do this framing from the novel engineering side. And then these video instructions will be put in this link, and this PDF will be shared with you also to have a look. This way, we are able to build a project through novel engineering eyes, using agile engineering as a development process, and then also using the testable code and also the video instruction and also the PowerPoint instructions for scaffolding, doing the project, and coming up with a solution. I trust this will actually drive us to the next level of iteration of the material, where we'll have a possibility to make this even better. For now, through the review meeting and the aspect of novel engineering to understand the problem first better before even delivering a solution has been triggered, and the whole class has been engaged. With that note, I would like to actually thank you for listening to this video so far, and then I would love to get your feedback and suggestions in the future. Thank you very much for listening so far.